So welcome to 2020 Geological Geometry question. It's the high level question, question C-1. The accompanying map located on the back of section A shows the ground contours at 5 metre vertical intervals on a foot golf course. Okay, so we've got our map here. ABC is the edge of a proposed fairway. ABC here is the fairway. And point O is the centre of a circular curve which forms part of the putting green. Okay, so we've got our fairway where you hit your ball up and your putting green over here. Fairway ABC and putting green have the following specifications. Circular putting green is at a level of 60 metres. So I'm just going to say in here that's at 60 metres, that entire thing. The section of the fairway from A to B is level at 60. So A is at 60 and over here to B is at 60 as well. The section of the fairway from B to C has a gradient of 1:5 rising. Okay, so it's rising for every 15 that it travels, it's rising 1 metre. Okay, using slopes of 1:1 for cutting, so our cutting is 1:1, and our embankments are 1:1.5, so that's our fill is 1:1.5. Complete the necessary earthworks necessary to accommodate the putting green and the fairway on the northern side. Okay, and we've got our good indications to say the northern side. We're not concerned with down here. Okay, so our cut, first of all, we've got 1:5 or 1:1, and our gradients there are in 5 metre intervals. So we've got our cut there of 5, 5, and our fill. So we're going up 5. That's 7.5 we're traveling there. Okay, so that's going to help us. First bit. So we'll start with all the level portions. Okay, so we'll go from O, A to B. That's all going to be level. Okay, at a height of 60. So I'll start with O. So we've got a height of 60. I've got 55, 50. So we're going to be filling in there. I'll just draw a line over here so we can take measurements along. So we're filling, and they're going to be 7.5 mil intervals. So that's 60, 55, 50, 45, and there's no 4. Okay, so I'm just going to use my center O. Swing those arcs all the way around. Okay, so we're at 60 here, so 60 doesn't intersect, then we're to 55. Okay, my 60 will be somewhere over there. So 50, 45, 45, after 50, 55, and then 60 will be right there. Okay, so let's draw that contour. And the 60 is somewhere up there, do you know that? Contour comes somewhere down, so let's just draw it out there somewhere. Right, then from A to B, it's at a level of 60 again. And if we look at our measurements, our contours, we've got 65, 70, So there's nothing below 60 there, so we're going to be actually cutting. So 5 meter intervals for that. I'm going out distances of 5. Okay, so 60, 65, 70, 75, 80, 85. I don't know what I mean to 85, we don't. Okay, so that's 60, here's 65, 70, 75, 80, 85, and back down again, and B is at 60. So that's our contour. Running up, back down to B. Okay, so pretty straightforward so far. Now we're going from B to C. Okay, they don't tell us the height of C, but they do tell us that B to C has a gradient as 1 to 15 rising. Okay, so 1 to 15 rising. So for every 15 meters that I travel out, I go up 1 meter. Okay, so what do I do here? I want to find, so if I come out, I want to find where height 65 is. Okay, so that would be rising 5 meters. So if I was to redraw this again, I want to rise 5 meters to find 65. So if I've gone up 5 meters, so I multiply that by 5, let's multiply 15 by 5, and that's 75, yeah. So if I measure out 75 here, at this position, we are at 65. Okay, so what I'll do is look at what's happening. We're going contours, there's 45, 50, 50. Okay, so all of that is lower than our height of 60 to 65. So we're going to be filling again there. So our fill is 5 meter intervals, 5 meter intervals. Okay, so we're going to be 7.5, get my compass and I draw my cone. 7.5, I'm just going to use the height that I've done here, 7.5, it's easier for me to measure, more accurate than my set square. So I've got 4, I'm going from B to C. Okay, so that's at a height of 60. So let's go out in our 7.5 meter intervals again. Set squares, so that's it. 60, 55, 50, 45, 40, I'm just seeing there's actually 35, so I'll measure another 7.5 out. Just in case I need it. Okay, so we're at 60, so we're going to 55, 50, 45, 45, into 50 again, 50 again, 45, 40, 35, 30. Just a lot of up and down here. Okay. So that is our contour. unusual to get one doing up and down like that, but it's nice to do. Okay, so that is the contour. So we've got a fill, cut and a fill. So you can colour them in or label them yourself. So that's part A completed. Part B then. A football is positioned at D. So it's positioned here at D. And is kicked in a westerly direction. So we're going back to our map. We've got north, south, east, west. So westerly direction. So it's kicked this direction. The path of the ball is parabolic. Okay, so we have to draw a parabola here, I'd say. The vertex of the parabola is located at an altitude of 65 and it is 60 meters west of point D. So we're going to have a parabola. Point D is here because we've kicked it west. They're telling us D is at a height of 65. You can see it there, and they've given to us. So that's at 65. They're telling us the vertex, the top of the parabola, is at 95, isn't it? 95. And it's 60 meters from D. So that distance from there to there is 60 meters. Okay, so let's go up to our down here. So D and D is positioned. And let's put in our intervals then, our height intervals. So that's 65, 70, 75, 80, 85, 90, 95. Those are our heights. And then our vertex is 60 away. So that's our vertex. V. And I'll just measure out to find the opposite side. Okay, so we've already got divisions there, so these in 95. Yeah, that's at 90. Okay. And what we do is we want to split this up into this 1, 2, 3, 4, 5, 6 sections. Great. So we need to measure in 10mm intervals. If you want to do the construction for dividing a line into equal parts, you can. There's no real need. You can save time like that in an exam. Always take advantage of it. Those are rational numbers. Okay, and show those splits over here. Okay, join all these back. Okay, so this is our parabolic curve, path of the ball. Okay. So in the space provided at the top of the map, draw the parabolic path and determine the position of the point on the green where the ball initially lands. Okay, so there's our parabola. It's telling us it's landing on the green, but the green is a height of 60. So we actually need to come down 5 millimeters here to that height of 60. Okay, so that's the height at which it lands at. So we can't just draw that out, but it will be coming out there somewhere. So let's measure out another 10 mil into it. Okay, and that should be the position . Okay, should to extend these numbers out. That's there. That's 60. The ball is going to come and cross along here somewhere. So I need to find another point out here. So, right there. Okay, so that is the bottom there, that parabola. So this is going to travel down. That's the path of the ball, but it stops at a height of 60 because our green is at a height of 60, and that's the path of the ball there. Okay, so that's the point at which it lands. Okay, that's a nice, interesting one. Okay. On a separate diagram on the map, so over here, the elevation plan and plan of 2 skew boreholes from points P and Q are shown. Okay. The borehole P reveals the top and bottom surfaces of the stratum. So borehole P, we've got the header and the foot, and respectively, yeah. And Q reveals the top and bottom, so Q we've got it as well, our header and our foot. The elevation and plan of a portion of the bottom surface of the stratum is also given. So they've given us a portion here of the stratum. Right? And they want us to determine the dip, strike, the strike, dip and thickness. So, what we'll do is we'll find the strike first of all. Very easy. It's a level line on this plane that they've given us. So from PF, so project it down onto this line from Q. Yeah. So QF there. Back to PF. That is our strike. Okay, so now we're going to take an auxiliary looking out perpendicular to that, or seeing the strike as a point view. Just around here, we'll go X1 line. Okay, we'll project up QH, PH, PF, QF. Okay, so this is an auxiliary elevation, so X1, Y1. We take our heights from our elevation. So start here with QH down to our XY line. QH out. I don't need to extend that in a moment. PH. There. PF. PF. And finally, QF. so let's think that out. That's our Q, H, P, H, P, F, Q. Alright. So that's their projections. Okay, and our dip. Right, those are same, the parallel, so I'll just give it a bit of space, I'll show it here. That's going to be my dip, and my thickness then. That's going to be my thickness. I'll take that out here. Thickness T, and this is our dip angle. Determine. So let's measure those. Dip is 29 degrees. So thickness there 9. Okay, dip, strike, thickness, complete. Okay, so that was the geological geometry question, the higher level geological geometry question on 2020.